there's questions like this that show up on WebWork, which is why I'm doing this one, because you're asked a question like here, example 7, 2 to the 50, was it 50,000? Yeah, 50,000 power has how many digits? And some students try to do it an easy way, so I'm just going to put that in my calculator. Well, guess what? It doesn't work. I mean, even if it did, it'd probably go into scientific notation, but this one's so big, you get some kind of overflow error. So no, basically, the calculator say, nope, too many numbers, too many digits, can't handle it. And some students will try to go to a computer, and a computer might have trouble with this, depending on what kind of operating systems you have, what kind of software you have on it, that sort of thing. So in this kind of situation here, we're going to use a premise that we have up here. It says, given positive integers a and x, there exists an integer n such that n minus 1 is less than or equal to the log of a to the x power, which is less than n, where n represents the number of digits in a to the x power. So what this basically says is, okay, if I want to figure out how many digits are in here, and also keep it in perspective, because of the exponential rule or the exponent rule of logarithms, log of a to the x power is the same thing as x times log of a. That a there is not meant to be looking like a base. It's meant to look like it's supposed to be log of a, not log base a of nothingness. But just didn't come over really well whenever this thing was saved. So what I'm going to do here is I'm going to do a logarithm of 2 to the 50,000 power and see like what it falls between, because I mean it's going to fall between. I'm going to see what two integers it's going to fall between. The difficulty I'm going to have with this is if I try to put the log of 2 to the 50,000 power in my calculator, it's still going to have a problem with it, because the calculator is a program with the order of operations. It's going to try to do 2 to the 50,000 first, get an answer, do a logarithm of it. Unfortunately, when it tries to do the 2 to the 50,000 part, it's going to have an overflow and won't be able to do it. You can do this more by hand than calculators and computers could do it, because we have other rules of logarithms. For instance, I could turn this into 50,000 times the log of 2, which becomes a lot easier to do on the calculator, because log of 2 is a pretty tame number as far as its size is. It's not a good, nice rational number. It's an irrational number to say the least, but it's still relatively small in size. And 50,000 times that is still very doable. So if I do 50,000 times log 2 on my calculator, I get about 15,051.49978 blah blah. There's more numbers that follow, but that all I need is this. Because I'm looking for, n's an integer, n minus 1 is an integer. I'm looking for an integer that's more than, that's the 15,051.4. So the next integer up, which means that, 15052 is what I'm looking for, because, I mean, the other end would be 15051. So this number is between these two integers, and the one on the right is my n value. So essentially, this is going to have 1,000 or 15,052 digits. I don't know what the digits are, mind you. I don't know specifically what they are, but there would be 15,052 of them.